Okay, guys, rate of change, okay? So we have three things we have to be able to do today, okay, is using the rate of change, okay, also known as delta y over delta x. I'm going to explain that in a second, which is the same thing as slope, okay? Using the rate of change from a table, okay, to do what? To find the rate of change, to determine if that's linear or nonlinear, and then write the equation, okay? So blast from the past, I'm going to do a little reminder, okay? So we are able to write the equation of this line just by looking at it on the graph. How did we do it before? Well, you have y equals mx plus b, and then we did y equals blank x plus blank. You don't have to write this down. Just listen. I'm just reminding you guys, okay? So this is a -1, by the way, right there. First of all, where does this line cross over the y-axis? At a -1, okay? So we're halfway done with writing the equation of a line. And then you have to determine the slope of this line. So you have to, how did I get from this point to like this point? And you could say up to 3, 4 over 1, 2. So that would be y equals 2x minus 1, okay? So as a reminder, that is how we write the equation of a line just by looking at it on the graph. Well, we're going to do the same thing. We're going to do the same thing, you guys. We're going to write the equation of a line. So everyone go ahead and write y equals mx plus b, okay? And then y equals blank x plus blank. We're going to be able to write the equation of a line now by using the information from the table. So let me say that again. Okay, we are able to write the equation of a line by looking at it on the graph. Now we have to do the same thing. We have to write the equation of a line by using the information in the table. How do we do? We have to fill in the slope and the y-intercept. So everybody circle the slope. Okay, do that. Draw an arrow to it and write rate of change. Exclamation mark. Why is my handwriting so off today? Don't care. Go with it, people. Okay? Whatever. The rate of change, okay, is the slope. But how do you determine the slope, the rate of change, by looking at it in a table? Okay? Well, it's called the change in y over the change in x. Okay, so, I could say m equals, this is the same as, the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It's the same thing, okay? Please get that in your head. Only they don't give you the 2 points that we can use to fill this in. We're just looking at it in the table. So this is how you find the slope or the rate of change, by looking at it on the table. So you're going to, the change in y, what does that mean? The change in y means, how did we get from a -3 to a -1? You're basically looking for the sequence, right? We added 2. How did we get from a -1 to a +1? We added 2. Write this in your notes with your table. How did we get from a +1 to a +3? We added 2. How did we get from a +3 to a +5? We added 2. That is the change in y. Now the change in x. How did we get from a -1 to a 0? We added 1, added 1, added 1, and added 1. Okay? So guys, if we were to fill this in, what is the change in y? A +2, so we put 2. What is the change in x? We put 1, so there you have it. So our rate of change, okay, when you simplify, our rate of change is a +2. So what do we put here for m, for slope? 2. Now let me show you how easy this is, guys. Can anyone tell me what the y-intercept is just by looking at the table? Can anyone tell me what the y-intercept is just by looking at the table, the information on the table? Anyone? No. Okay. Well, the y-intercept is where the line crosses over the y-axis, right? Where the x value is 0. Look at this, guys. Our x value is 0. So our y-intercept is what? A -1. -1. You just wrote the equation of a line by looking at it on the table. Does that make sense? Okay. So now we have to determine if it's linear or nonlinear. Okay. Here's the clue. Here's part 2. Linear means, is it a line? Everybody circle the word line. Is it a straight line? That's what linear means. Non-linear means, is it a parabola? Something like that. Or, is it something that it increases, starts out low, but it increases, it's still a function, but it increases super fast. Okay. But nonlinear is anything that's not a line. If it's linear, it will increase the same every time, the same +2, +2, +2, +2. That, everybody write linear. Okay, that is your clue that you're dealing with a linear function. It would be nonlinear, okay, if it looked like something like this. Watch, if it was like +8, +16, +32, if it was increasing but like a different number every time, that is your clue that it's rapidly increasing. Okay, that is your clue that is non-linear. Okay, just by looking at it on the table. All right. Now, and we already wrote the equation, you guys. We did what we needed to do here. We wrote the equation just by using the information in the table. Okay. Now, pretend you did not know that this was our y-intercept. Pretend you didn't know that, okay? What is our backup plan, okay? Supposing we didn't know that this y-intercept was a -1 and we still had to solve for b. Right? You could choose any one of these points in the table and just solve for b like we always have before, right? We do empty equals 2 empty plus b. And of course, I'm going to choose the easiest point possible here, right? And you put in your y value and your x value and just do the math. So 1 equals 2 plus b. Subtract 2 from both sides. B equals -1. And then we put it up here and put our -1, and we wrote the equation of a line. And it's okay. Like if you forget, okay, that the y-intercept in the table is the point that has the 0, okay, as its x value. If you forget that, then choose any one of these points and solve for b. Okay, but it's really helpful to know that that's your y-intercept right there. To complete, when you're writing the equation. And that's it. So we're going to do another practice example.